All right, hello everyone. I am here again to talk to you about the laws of probability and how they govern Mendel's law of inheritance. And these same laws of probability can be used to predict the outcome of a roll of dice, or your chances of getting heads or tails, or the probability of you pulling a certain card out of a deck. They're not just applied to genetics. So if we look here for a coin, and where we're going to use these probabilities is when we get into more complicated crosses, okay? If you've already seen how to do the die hybrid cross, it's cumbersome and it takes a long time. But now try looking at when you're looking at 3 or more traits. Well, we've got to come up with a quicker way of doing this. So this is where we apply these rules. Now, I'm going to suggest that we sort of apply these rules for this class until you get better at visualizing your genetics. I would like for you to still draw monohybrid Punnett squares. That will help you see where these traits come from, and you can use that to then apply it to your dihybrid, your trihybrid, your whatever hybrid crosses, okay? All right, so let's just look at this super simple, compare what we know. What would be your probability of tossing a coin? And again, these are where we would use independent, meaning your probability of one toss has no impact on the next toss. So what's your probability of tossing heads each time? Every time it's going to be 50%. Now, let's take it on a genetics way. Let's say you've got a parent that's got a big B, little b. What's the probability that they're going to have a gamete, meaning a sperm or an egg, that has a big B? Well, again, it's 50%, okay? That percentage doesn't change. Every time it's a 50% chance of getting a big B. 50-50, okay? So the rule of multiplication, this is where things get confusing. You have two rules, the rule of multiplication and the rule of addition. I'm going to tell you now, we're mostly going to use the rule of multiplication. When you see the word and in a problem, that means that you're going to use the rule of multiplication to make your life easy. Unless you don't want to draw Punnett squares, you really won't use the law of addition in this class, okay? I would like to get there, but we're going to keep it simple this year and say, let's just use the rule of multiplication most of the time. I want you to understand there's two laws. I want you to understand why we would apply the rule of multiplication versus the rule of addition. But if you draw your Punnett squares for your monohybrids, you won't really use this rule of addition. So basically, the rule of multiplication is when we have two or more independent events that will occur together in the combination. So this would be the idea of what are the chances if you have two coins that you're going to get heads each time. So that would be the big R here or the big R here. Or if we took this as a sperm and an egg, what are the chances that each of these would give a big R? So it's half here and half here. So half times half equals 1/4. And if you look at the Punnett square, you end up with 1/4 of a chance of getting big R, big R. Okay, I'm going to skip that slide and just move on to this one. Chances that two or more independents will occur together. That's the rule of multiplication, okay? So it's like the probability that two coins tossed at the same time will land heads up. Well, that's just two independent events. One, that it's a half a chance that one will land on heads. The other one has a half a chance. So we end up with 1/2 times 1/2 equals 1/4. What is the probability? We're just going to take this on a genetic level of two heterozygotes producing an offspring with little p, little p. Well, each can only get, what's the chance of getting a little p out of here? Half and half. So we multiply those together and we get 1/4. Okay? Okay, so this is just going to show you where we might want to use it. If you've drawn your dihybrid cross now, you know how much work that is. So what we could do is say, what's the probability? And use this rule of multiplication so we don't have to draw that big thing. What are the chances of the offspring ending up with a little y, little r, little r? Now this is where I'm saying it might just be easier for you all now to draw your Punnett square. And if you draw your Punnett square, you have two heterozygotes, and you end up with this, okay? And what are the chances of ending up with a little y, little y? Well, if you look here, I'll try to find a way to circle that for you or color that box in. You end up with 1/4 of a chance of getting little y, little y. Now, if you use the rule of multiplication, then you would say that the first parent has half a chance and the second parent has half a chance. So the total equals 1/4. So you still get 1/4 either way. Again, I kind of prefer you just draw the Punnett square. All right? Now, what are their chances of each one giving a little r? Well, again, if you draw your Punnett square, you end up looking here, and again, you'll start to get the hang of this and not even have to draw the Punnett squares because you know what the Punnett square is going to look like. You end up with 1/4. If you did the actual math way, you would do 1/2 times 1/2 equals 1/4. Now, what are the chances of these two independent events happening at the same time? You multiply these two together, 1/4 times 1/4. And I'm not sure if you can see that 1/4. That's what I'm trying to check here. You end up with 1/16 of a chance, okay? So let's apply this to even a harder problem. If you had these two combining, imagine drawing that Punnett square. What are the chances of getting this offspring? Again, I would recommend drawing the Punnett squares, and that's how I'm going to work this problem for you because there's only so much time on a video. But you could also do the way I showed you where you do the rule of multiplication, and if you have a heterozygote, two heterozygotes, and they want to know the chances of getting a heterozygote, that's where you're going to have to apply the rule of addition. However, we are just going to do it with the Punnett squares to keep it simple because I find this is the probably easiest way for most of you guys to get this the fastest and the easiest. So what are the chances of getting little a, big A? We'll draw the cross. Big A, cross with big A, little a, okay? And these are your offspring. They want to know what are your chances of getting big A, little a. You have a 50% chance or 1/2, okay? And that's what that's showing. Okay, what are your chances of getting a little b, little b? Well, what I'm going to really suggest is that you draw the cross, okay? And you have a big B, little b, and the parent has a big B, little b. And at this point, you should have memorized two heterozygotes have a 1/4 of a chance, but there's your Punnett square to prove it, of having a little b baby, right? This guy right here that's colored in orange. So you have 1/4 of a chance. 1/4, okay? And this keeps going for each one. Now, I'm not going to work every one of these Little c, well, that's pretty easy. Just one. That's the only thing that can happen. Big D, little d. What are your chances of having a heterozygote? 1/2. I do want to just show you this one because this is one of those where the D can come from, this can happen two different ways. You could get the big D from the mom, or you could get the big D from the dad. So you would have to use, oh dear, I'm sorry.